Hello students, welcome to your channel Parivartan Physics. See, in today's video, we'll solve 5 mark numerical problems from model question paper 1 of academic year 2024-25. Andre recently in model question paper, more model question papers release agidava from KCET, I mean from PU Board. Our model question paper, first model question paper, 5 marks numericals. We'll solve those 5 mark numericals in today's video. Right? Okay, so let us begin the video then. See, we'll go for the first question. See, first question ಏನದಪ್ಪ ಅಂತಂದ್ರೆ they are told calculate the potential at point P due to a charge of 400 nanocoulomb located 9 cm away. ಅಂದ್ರೆ ಈಗ ನಮಗೆ ಇಲ್ಲಿ ಏನು ಮಾಡಿದ್ದಾರೆ, there is a charge of 400 nanocoulomb. ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಅದ ನಮಗೆ whose value is 400 nanocoulomb. ಈ 400 nanocoulomb ಚಾರ್ಜ್ ದಿಂದ ಒಂದು ಪಾಯಿಂಟ್ ನಮಗೆ P ಅಂತ ಪಾಯಿಂಟ್ ಅದ which is at a distance of 9 cm. Which is at a distance of 9 cm. So at this point, how much is the potential? This is the first thing we have to calculate. At this point, how much is the potential? That is the first thing we have to calculate. Second question is what they are asking. Obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. Andre, again namagu point P adala. This is 400 nanocoulomb charge. 400 nanocoulomb charge. From 400 nanocoulomb charge at a distance of 9 cm, we have taken a point P. ಈಗ ಇನ್ಫೈನೈಟ್ ಡಿಸ್ಟೆನ್ಸ್ ದಿಂದ ನಾವು ಒಂದು ಚಾರ್ಜ್ ಅನ್ನು ತಗೊಂಡು ಬಂದು ವೇರ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಕೀಪ್ ಇಟ್, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಕೀಪ್ ಇಟ್ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ. ಸೊ ವಿಚ್ ಚಾರ್ಜ್ ಐ ಆಮ್ ಮೂವಿಂಗ್ ಎ ಚಾರ್ಜ್ ಆಫ್ 2 nanocoulomb ಫ್ರಮ್ ಇನ್ಫಿನಿಟಿ ಟು ಪಾಯಿಂಟ್ ಪಿ. ಸೊ ಹೌ ಮಚ್ ಇಸ್ ದ ವರ್ಕ್ ಡನ್? ಈ ಮೂಮೆಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತದೆ, ದಟ್ ವರ್ಕ್ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್. ಅಂಡ್ ವಾಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್, ಡಸ್ ದ ಆನ್ಸರ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಪಾತ್ ಅಲಾಂಗ್ ವಿಚ್ ದ ಚಾರ್ಜಸ್ ಮೂವ್? ರೈಟ್, ಆ ಪಾತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೋ ಇಲ್ಲೋ ಅಂತ. ಇಫ್ ಐ ಬ್ರಿಂಗ್ ಇಟ್ ಲೈಕ್ ದಿಸ್, ಆರ್ ಇಫ್ ಐ ಬ್ರಿಂಗ್ ಇಟ್ ಲೈಕ್ ದಿಸ್ ಸ್ಟ್ರೇಟ್ ವೇ, ಆರ್ ಇಫ್ ಐ ಬ್ರಿಂಗ್ ಇಟ್ ಲೈಕ್ ದಿಸ್, does it depends upon the part that they are asking? Okay, we'll see that later in detail. Okay, first we'll solve the question number A. See, potential now calculate ಮಾಡಬೇಕಾಗಿದೆ. Point charge the potential the formula apply ಮಾಡ್ರಿ. Point charge the potential formula V is equal to 1 by 4 pi epsilon naught Q divided by R. This is the formula of potential of point charge. We know very well 1 by 4 pi epsilon naught is 9 into 10 raised to 9. 9 into 10 raised to 9. Charge is 400 nanocoulomb. 400 nanocoulomb. Nano means it is 10 to the power minus 9. Divided by R. R is 9 cm, take it in meter. 9 into 10 to the power minus 2. Right? Okay, here 9 and 9 will get cancelled. 10 raised to plus 9, 10 raised to minus 9 will get cancelled. So I will get 400 divided by 10 to the power minus 2. It will be 10 to the power plus 2. 10 to the power plus 2. Or I can write it as 4 into 10 to the power plus 4. Illen double zero the way the 10 to the power plus 2 on the 4 into 10 to the power plus 4. This much will be the potential at point P. Point P ಒಳಗೆ ನಮಗೆ potential ಎಷ್ಟು ಇರ್ತದೆ. Or you can also write it as 40 kilovolt ಅಂತ ಹೇಳಿ ನೀವು ಬರಿಬಹುದು. 40 kilovolt ಅಂದ್ರೆ 40 into 10 raised to 3. That can be written as 40 kilovolt also. Okay, so this is the potential at point P. Okay, now come for question number B. See, we already know how much is the potential here. ಈ ಪಾಯಿಂಟ್ ಪಿ ಒಳಗೆ ಎಷ್ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಅದ ಅದು ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತದ. 4 into 10 raised to 4 volt. This much is the potential at point P. ಸೊ ಆ ಪಾಯಿಂಟ್ ಒಳಗೆ ನೀವ್ ಏನ್ ಮಾಡೋದ್ರಿ, 2 nanocoulomb ಅಂತ ಒಂದು ಚಾರ್ಜ್ ನ ಇನ್ಫಿನಿಟಿ ದಿಂದ ತಗೊಂಡ್ ಬಂದು ಅಲ್ಲಿ ಇಡೋದ್ರಿ. ರೈಟ್, ಸೊ ದ ಇನಿಷಿಯಲ್ ಪೊಸಿಷನ್ ಆಫ್ 2 nanocoulomb ಚಾರ್ಜ್ ಇಸ್ ಇನ್ಫಿನಿಟಿ. ಫೈನಲ್ ಪೊಸಿಷನ್ ಇಸ್ P. We are moving it from infinity to P. So we want to calculate the work done. So now work done calculate ಮಾಡಬೇಕಾಗಿತ್ರಿ. Work done is equal to, we know very well, potential is equal to work done divided by charge. So work done is equal to potential into charge. ಇದು ನೀವು potential difference ಅಂತ ತಗೋಬಹುದು. See, potential difference ಅಂತಂದ್ರೆ you should take it like this. Potential at final point minus potential at initial point into the charge. Okay, potential at final point. Potential at final point ಅಂದ್ರೆ ಏನ್ರಿ? Potential at point P. This is the final point. ಆ ಜರ್ನಿ ದ ಫೈನಲ್ ಪಾಯಿಂಟ್ ಪಾಯಿಂಟ್ P. ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಯಾವ್ದ್ರಿ? ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ ಇನ್ಫಿನಿಟಿ. ಇನ್ಫಿನಿಟಿ ಇಸ್ ದ ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ಇಂಟು ದ ಚಾರ್ಜ್ ಕ್ಯೂ. ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ ಪಾಯಿಂಟ್ P we already know it is 4 into 10 raised to 4. Potential at point P we already know it is 4 into 10 raised to 4. Potential at infinity will be 0. Potential at infinity will be 0. Why? ಯಾಕಂದ್ರೆ R ಜಾಗ ಒಳಗೆ ನೀವು ಇನ್ಫಿನಿಟಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ರಿ, it will become 0. Right? Okay, 0. And the charge which we are moving is 2 nanocoulomb. 2 nano means 10 to the power minus 9. So I will get it as 4 into 10 to the power plus 4 into 2 into 10 to the power minus 9. 4 into 2 will be 8. 8, 10 to the power plus 4, 10 to the power minus 9 ಅಂತಂದ್ರೆ ಎಷ್ಟಾಗಬೇಕು? It will be 10 to the power minus 5. 10 to the power minus 5. right? Okay, so 8 into 10 to the power minus 5 joule, this much has to be the work done. Is namak work done irbeku, this much has to be the work done. Next what they are asking, ಈಗ ನೋಡ್ರಿ ಆ ಕ್ವೆಶ್ಚನ್ ಇನ್ನೂ ಕಂಪ್ಲೀಟ್ ಆಗಿಲ್ಲ. ಅವ್ರು ಏನ್ ಕೇಳ್ತಾರೆ, does the answer ಅಂದ್ರೆ work done, does the answer work done depends on the path along which the charge is moved, ಪಾತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೋ ಇಲ್ಲೋ ಅಂತ ಕೇಳ್ತಾರೆ. ಸಿ ಪಾತ್ ಅಂತಂದ್ರೆ ಈಗ ನಾ ಇನ್ಫಿನಿಟಿ ದಿಂದ ಪಾಯಿಂಟ್ ಪಿ ಗ ಚಾರ್ಜ್ ಅನ್ನು ಮೂವ್ ಮಾಡತ್ತೀನಿ. ವಿ ಕ್ಯಾನ್ ಮೂವ್ ಇಟ್ ಇನ್ ದಿಸ್ ಪಾತ್, ವಿ ಕ್ಯಾನ್ ಮೂವ್ ಇಟ್ ಸ್ಟ್ರೇಟ್ ಲೈಕ್ ದಿಸ್, ವಿ ಕ್ಯಾನ್ ಮೂವ್ ಇಟ್ ಲೈಕ್ ದಿಸ್, ಆರ್ ವಿ ಕ್ಯಾನ್ ಮೂವ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಈ ತರ ನೀವು ತಗೊಂಡ್ ಬಂದು ಇಡಬಹುದು. ಸೊ ಇನ್ ಮೆನಿ ಪಾತ್ಸ್ ಯು ಕ್ಯಾನ್ ಬ್ರಿಂಗ್ ಇಟ್ ಅಂಡ್ ಯು ಕ್ಯಾನ್ ಕೀಪ್ ಇಟ್ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ. ವೆದರ್ ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ ಪಾತ್ ಆರ್ ನೋ ಅಂತ ಕೇಳ್ತಾರೆ. ಯಾವುದು ವರ್ಕ್ ಡನ್ ಪಾತ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದೋ ಇಲ್ಲೋ ಅಂತ ಕೇಳ್ತಾರೆ. ಸಿ ವರ್ಕ್ ಡನ್ ಫಾರ್ಮುಲಾ ನಾವ್ ಇಲ್ಲಿ ಬರ್ದೇವಿ. ವರ್ಕ್ ಡನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ ಫೈನಲ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಪೊಟೆನ್ಶಿಯಲ್ ಅಟ್ ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ minus potential at initial point into the charge q. ಅಂದ್ರೆ work done only depends upon the potential at final point and potential at initial point. Final point is potential, initial point is potential ಮೇಲೆ ಮಾತ್ರ ಡಿಪೆಂಡ್ ಆಗ್ತದೆ. It is not dependent on path followed. It only depends upon the potential at initial point and the potential at final point. Path it is nowhere related. ನೀವು ಯಾವುದೇ ಪಾತ್ ಫಾಲೋ ಮಾಡ್ಕೊಂಡು ಬರ್ರಿ, ಇನಿಷಿಯಲ್ ಪಾಯಿಂಟ್ ದಾಗ ಪೊಟೆನ್ಶಿಯಲ್ ಅಷ್ಟೇ ಇರೋದು, ಫೈನಲ್ ಪಾಯಿಂಟ್ ದಾಗ ಪೊಟೆನ್ಶಿಯಲ್ ಅಷ್ಟೇ ಇರೋದು. ಸೊ ಇಟ್ ಡಸ್ ನಾಟ್ ಡಿಪೆಂಡ್ಸ್. So here I have to write it does not depends on the path followed. It does not depends on path followed. It only depends on the initial and final positions. Path followed mega depend agangilla. It only depends upon the potential at initial point and potential at final. Right? Okay, that is all about question number 1. Let us go to the next question then. Next question. Okay, see, the next question is, in the following network find the current I3. I3 is the current here. ಇಲ್ಲಿ ನಮ್ಮ current ಅದ, ಈ I3 current ಅನ್ನ find ಮಾಡಬೇಕಾಗಿತ್ತು. See, 1 ampere current is entering the circuit. 1 ampere current ನಮಗೆ ಇಲ್ಲಿ ಎಂಟರ್ ಆಗತ್ತದ್ರಿ. ಆ 1 ampere current ನಮಗೆ ಎರಡು ಪಾರ್ಟ್ ಸ್ಪ್ಲಿಟ್ ಆಗಿತ್ತು, I1 ಮತ್ತು I2 ಅಂತ. So I2 means what I can take it as, I2 ಅಂದ್ರೆ ಇದನ್ನ ಏನಂತ ತಗೋಬಹುದು, I2 means I can take it as 1 minus I1 ಅಂತ ತಗೋಬಹುದ್ರಿ. I2 means ಯಾಕಂದ್ರೆ 1 ampere current ನಮಗೆ ಎರಡು ಪಾರ್ಟ್ ಸ್ಪ್ಲಿಟ್ ಆಗೈತ್ರಿ, I1 ಮತ್ತು I2 ಅಂತ. That's why I2 means I can take it as 1 minus I1. Okay, this is I1 and this is 1 minus I1. ಈ resistor ಒಳಗೆ ನಮ್ಮ current ಎಷ್ಟದಪ್ಪ ಅಂದ್ರೆ 1 minus I1. Okay, this is I3, then how much will be the current here? ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ನಮ್ಮ current ಎಷ್ಟು ಇರಬೇಕು? It will be I1 minus I3. I1 minus I3. Right, the current in this resistor. ಈ resistor ಒಳಗೆ ನಮಗೆ 10 ohm resistor ಒಳಗೆ current ಎಷ್ಟು ಇರಬೇಕು? I1 minus I3. Let me write it a bit clearly. Okay, so the current in this branch is I1 minus I3. I1 minus I3. Right? So I1 ನಮಗೆ ಇಲ್ಲಿಗೆ ಬಂದದ್ರಿ, I1 is I3 ಮತ್ತು it is already given here. ಇದು already ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. It is given here I1 minus I3 and this is I2 plus I3. Okay, ಇಲ್ಲಿ ಒಂದು ಸ್ವಲ್ಪ ನಾವು modify ಮಾಡ್ಕೊಳ್ಳೋಣ. See, here I have 1 minus I2, here I have 1 minus I2, here I3 is there. So this current is 1 minus I2, 1 minus I1. This current is 1 minus I1, this is I3. So ಇವು ಎರಡು add ಆಗಬೇಕ್ರಿ. I3 and 1 minus I1 will get added and then they will flow here. So this current will be I3 plus 1 minus I1. ಎಷ್ಟು ನಮ್ಮ ಕರೆಂಟ್ ಇರ್ತದೆ? I3 plus 1 minus I1. ಅಂದ್ರೆ I2 ಜಾಗದ ಒಳಗೆ I have substituted 1 minus I1. ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ರೆ ಇಷ್ಟು ನಂಗೆ ಕರೆಂಟ್ ಬಂತು. Clear? So first what I did, I have put the currents in all the branches. ಎಲ್ಲ ಬ್ರಾಂಚಸ್ ಒಳಗೆ ಕರೆಂಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ಆ ಕರೆಂಟ್ ನಾವು ಜಸ್ಟ್ I1 I3 ಟರ್ಮ್ಸ್ ದಾಗ ಮಾತ್ರ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. I don't want I2 ಅನ್ನೋ ಎಕ್ಸ್ಟ್ರಾ ಟರ್ಮ್ ನಾವಿಲ್ಲಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಬೇಡ. Okay, here to solve this problem you have to apply KVL. ಇಲ್ಲಿ KVL ಅಪ್ಲೈ ಮಾಡೋದು ಬಿಟ್ರೆ ಬೇರೆ ಏನೋ ಆಪ್ಷನ್ ಇಲ್ರಿ ನಮಗೆ. We have to apply the KVL. KVL ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ you should know the rules of applying the KVL. So ಜಸ್ಟ್ ನಿಮಗೆ ಶಾರ್ಟ್ ಕಟ್ ದಾಗ ಹೇಳ್ಬಿಡ್ತೀನಿ. KVL ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ನೀವು ಒಂದು ಡೈರೆಕ್ಷನ್ ತಗೋಬೇಕು, ಐದರ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಅಥವಾ ಕ್ಲಾಕ್ ವೈಸ್ ಯಾವ್ದಾದ್ರು ಒಂದು ಡೈರೆಕ್ಷನ್ ತಗೋಬೇಕು. IR products, current into resistance products in ಬರಿಬೇಕಾದ್ರೆ ನೋಡ್ರಿ, if this is the resistance and this is the current and if the direction is ನಾವು ತಗೊಂಡಿರುವಂತ ಡೈರೆಕ್ಷನ್ ಏನಾದ್ರು ಕರೆಂಟ್ ನ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅದನ್ನ ಆ ಪ್ರಾಡಕ್ಟ್ ನಾವು ಪ್ಲಸ್ IR ಅಂತ ತಗೋಬೇಕು. ಪ್ಲಸ್ IR, ರೈಟ್? ಇಫ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಇನ್ ದ ಬ್ರಾಂಚ್ ಅಂಡ್ ದ ಡೈರೆಕ್ಷನ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್, ಇದು ಬೋತ್ ಅಪೋಸಿಟ್, ಎರಡು ಅಪೋಸಿಟ್ ಇದ್ದು ಅಂದ್ರೆ ಪ್ಲಸ್ IR ಅಂತ ತಗೊಳ್ರಿ. ಇಫ್ ದೇ ಆರ್ ಇನ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್, ಅವು ನಮಗೆ ಸಪೋಸ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ದಾಗ ಇದ್ರೆ ದೆನ್ ಇಟ್ ಇಸ್ ಟೇಕನ್ ಆಸ್ ಮೈನಸ್ IR. ಅದನ್ನ ನಾವು ಮೈನಸ್ IR ಅಂತ ತಗೋಬೇಕು. ನೋಡಿ, ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ರೂಲ್ ಫಾಲೋ ಮಾಡ್ತಾರೆ, ಎಲ್ಲಾರ್ದು ರೂಲ್ಸ್ ಕರೆಕ್ಟ್ ಇರ್ತಾವ, ಬಟ್ ಇನ್ನ ಎರಡು ರೂಲ್ಸ್ ಮಿಕ್ಸ್ ಮಾಡ್ಬೇಡ್ರಿ. Follow any one rule, you will get the same results. Science ದಾಗ ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗ್ತದ್ರಿ, ಪ್ಲಸ್ ಮೈನಸ್ ಅಷ್ಟೇ ಚೇಂಜ್ ಆಗ್ತಾವೆ, ಬಿಟ್ರೆ ಉಳಿಕಿದೆಲ್ಲ ಸೇಮ್ ಇರ್ತದ್ರಿ. ಫೈನಲ್ ಆನ್ಸರ್ ಮಾತ್ರ ಎಲ್ಲರದು ಸೇಮ್ ಇರ್ತದ್ರಿ, ರೈಟ್? ಓಕೆ, ಸೊ ಫಾಲೋ ಎನಿ ಒನ್ ರೂಲ್. ಸೊ ನಾ ಈಗ ಏನು ಈ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ಲಿಕ್ಕೆ ರೂಲ್ ಫಾಲೋ ಮಾಡೋದಿಲ್ಲ, ದಟ್ ರೂಲ್ ಐ ಆಮ್ ಟೆಲಿಂಗ್ ಹೌ ಟು ಅಪ್ಲೈ ದ KVL ಅನ್ನೋದು. ಓಕೆ, ಈಗ ನೋಡ್ರಿ ಸೆಲ್ದ EMF, ಇಲ್ಲಿ ಸೆಲ್ದ EMF ಅಂತೂ ತಗೊಳ್ಳೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ನೋವೇರ್ there is cell in the loops. ಇಲ್ಲೊಂದು ಲೂಪ್ ಅದ, ಇಲ್ಲೊಂದು ಲೂಪ್ ಅದ, there is no cell here. Okay, that is not required. That is not required. So these are the rules we are going to follow. Okay, first we have to put the direction. ನೋಡ್ರಿ ನಮಗೆ ಇಲ್ಲಿ ಎರಡು ಲೂಪ್ ಅದಾವ. This is the first loop and this is the second loop. So ಈ ಎರಡು ಲೂಪ್ ಗೆ ನಾನು ಒಂದು ಡೈರೆಕ್ಷನ್ಸ್ ಹಾಕೋತೀನಿ. I will put the directions for both the loops. Okay, for both the loops I have put the directions. Now go on writing by applying the KVL. Okay, ಈಗ ನಾ ಲೂಪ್ ಗೆ ಇಲ್ಲಿ ನೇಮ್ ಕೊಡ್ತೀನಿ. Let me name the loops A, B, C, D, this is E, and this is F, right? Okay, let us apply the KVL for these loops now. Okay, I will apply KVL for loop, KVL for loop ABEF, A. For this loop, I am going to apply the KVL now. Okay, if I apply the KVL, first nodri, illi IR product baride. How much is the current here? I1 is the current in this resistance. Resistance is 10 ohm. The direction which we have taken and the direction of current both are same. This I1 current namaga ee direction olage flow agatadre. I1 current. The direction which we have taken, these both are in same directions. They both are same. Same idre now minus tagobeka. So minus, sign is minus 10 I1. Minus 10 I1. Next, you go for this branch. ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ಕರೆಂಟ್ ನಮಗೆ I3 ಅದ, ಡೈರೆಕ್ಷನ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ದಟ್ ಇಸ್ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ದಾಗ ಇರೋದ್ರಿಂದ ನೋಡ್ರಿ ಡೈರೆಕ್ಷನ್ ಸೇಮ್ ಅದ, ನಾವು ತಗೊಂಡಿರೋ ಡೈರೆಕ್ಷನ್ ಈ ತರ ಅದ್ರಿ, ಲೈಕ್ ದಿಸ್. ಸೊ ಕರೆಂಟ್ ಅಂಡ್ ದ ಡೈರೆಕ್ಷನ್ ವಿಚ್ ವಿ ಹ್ಯಾವ್ ಟೇಕನ್ ಬೋತ್ ಆರ್ ಸೇಮ್. ಅದಕ್ಕೆ ನಮ್ಗೆ ಅದು ಏನಾಗಬೇಕು, minus 5 I3, resistance is 5, current is I3, right? minus 5 I3. Next, ಈಗ ಈ ಕಡೆ ಬರಬೇಕಾದ್ರೆ ನೋಡ್ರಿ ನಮ್ ಡೈರೆಕ್ಷನ್ ಹಿಂಗದ, ಕರೆಂಟ್ ಡೈರೆಕ್ಷನ್ ಹಿಂಗದ, ದೇ ಆರ್ ಅಪೋಸಿಟ್ ಇನ್ ಡೈರೆಕ್ಷನ್. ಸೊ ಡೈರೆಕ್ಷನ್ಸ್ ಒಳಗೆ ಅಪೋಸಿಟ್ ಇದ್ರೆ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಟು ಟೇಕ್? I have to take it as plus, right? I have to take it as plus. Okay, plus 20, current is 1 minus I1. Resistance is 20, current is 1 minus I1. Current is 1 minus I1. Is there any EMF in the loop? There is no EMF. That's why I will take it as equal to 0. Adana idana equal to 0 anta tagondini. Okay, so this will be minus 10 I1, minus 10 I1, minus 5 I3, minus 5 I3, plus 20. 20 into 1 will be plus 20. Plus into minus minus 20 I1 equal to 0. Shift this pure number on the RHS. Idu nange minus 10 I1 ಆಗ್ತದೆ, minus 5 I3, minus 5 I3, minus 20 I1 equal to minus 20. This much I will get. Okay, I1 terms ನಮಗೆ ಇಲ್ಲಿ ಎರಡು ಅದಾವ್ರಿ, minus 10 I1, minus 20 I1. We have two I1 terms here, correct? Okay, so two I1 terms ಇರೋದ್ರಿಂದ ಇದು ನಮಗೆ minus 30 I1 ಆಗ್ತದೆ. Minus 30 I1 minus 5 I3 equal to minus 20. Anything I can take common here? Minus 5 na common tagobodre. If I take minus 5 common, this will be 6 I1. This will be okay, plus I3, and this will be plus 4. Let this be equation number 1. Idu namaga equation number 1 antiri, right? Minus 5 na common tagondideni, right? Okay, next I will apply KVL for the second loop now. KVL for loop second loop. Second loop the name ಏನದ BCDEB, right? BCDEB, right? This, for this loop we have to apply the KVL. Okay, ಈಗ ಈ ಲೂಪ್ ಗೆ ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ ನಮಗೆ ಡೈರೆಕ್ಷನ್ಸ್ ಹೆಂಗದ ನೋಡ್ರಿ. ಡೈರೆಕ್ಷನ್ಸ್ ಆರ್ ಲೈಕ್ ದಿಸ್, right? So first you apply KVL here. ಇಲ್ಲಿ ಕರೆಂಟ್ ನಮಗೆ ಈ ಡೈರೆಕ್ಷನ್ ಹೋಗಿದ್ರೆ what is that current? It is I1 minus I3. The current is I1 minus I3. Currents are in same direction, that's why we have to take a negative sign, minus, and how much is the current, how much is the resistance? 10 I1 minus I3, right? So this is 10 I1 minus I3. ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ನಮಗೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಲ್ಲ. ಕಮ್ ಟು ದಿಸ್ ಬ್ರಾಂಚ್. ಈ ಬ್ರಾಂಚ್ ಒಳಗೆ ನಮಗೆ ಡೈರೆಕ್ಷನ್ಸ್ ಅಪೋಸಿಟ್ ಅದಾವ್ರಿ. ಅಪೋಸಿಟ್ ಇದ್ರೆ ಪ್ಲಸ್ 5 into the bracket. How much is the current? I3 plus 1 minus I1. I3 plus 1 minus I1. Okay, come to this branch now. E branch barre. Directions are opposite directions idre plus. How much is resistance? 5. Current is I3. So this will be plus 5 I3, right? There is no EMF in the circuit, in the loop. That's why equal to 0. Okay, so I will get it as minus 10I1 plus 10I3 minus into minus plus 10I3 plus 5I3 plus 5 minus 5I1 plus 5I3 equal to 0. Correct? Okay, I3, I1 terms notary first test minus 10I1 minus 5I1. Right? How much I will get? Minus 15I1 I will get. Minus 15I1 plus 10I3 plus 5I3 plus 5I3. 10 plus 5, 15. 15 plus 5, 20. So plus 20I3. Shift this plus 5 on that side, you will get it as minus 5. Correct? So again, what I can take common? I can take minus 5 common. If I take minus 5 common, I will get it as 3I1 plus minus 3I1 minus 4I3 equal to plus 1. Right? This much I will get. Let this be equation number 2. Right? We applied KVL for first loop as well as for second loop. By applying KVL, we got these equations. Equation 1 and 2 namak bantri. So solving equations 1 and 2, we will get the answer. So first equation is 6I1 plus I3 equal to 4. Second equation is 3I1 minus 4I3 equal to 1. Okay, we have to solve these, equal to 1. We have to solve these equations. See, I will multiply this equation by 3 and I will multiply this equation by 6. What I will get? 3 into 6, it is 18I1 plus 3I3, 4 into 3, this will be 12. Right? Okay, 6 into 3, this will be 18I1, 4 into 6 will be minus 24I3 equal to 6 into 1 will be 6. Correct? Okay, let us change the signs and solve this. Minus plus minus. Plus 18I1 minus 18I1 will get cancelled. 24 plus 3, this will be 27I3 equal to 12 minus 6 will be 6. This is 6. So I3 is equal to, I got it as 6 by 27. It means it will be equal to 2 divided by 9. 2 divided by 9. Right? 2 3s are 6, 2 9s is 27. Okay, then see, let us calculate this. Okay, so this will be 2 divided by 9. 2 divided by 9, that is 0.22. Right? So I3 we got it as 0.22 ampere. So this much will be the current. 0.22 ampere is the current in that is I3. I3 we have to find. Right? I hope you understood this. You should know how to apply the KVL clearly. Okay, let us go to the next question then. So the next question is, an AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between the current and voltage. ಯಾವುದು ಲೀಡ್ ಆಗ್ತದೆ ಮತ್ತು ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ ಅಂತ ಕೇಳ್ತಾರೆ. See, current is leading or voltage is leading. ಎದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದ್ರಿ? It depends upon the values of XL and XC. You remember this, if XL is greater than XC, then voltage leads current. If XC is greater than XL, then current leads voltage. So we have to calculate XL and XC here. Then only we can say whether the current is leading or lagging the voltage. Okay, let us calculate XL first. XL calculate ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ನೋಡ್ರಿ, XL the formula ನಮಗೆ ಏನದ 2 pi FL, right? So 2 pi 3.142 into F is 50 into L is 1. So 50 into 2, it will be 100 into 3.142. 100 into 3.142 means it will be 314.2 ohm. XL means it is inductive reactance, opposition offered by inductor. That's why it will be in ohm. Correct? So we got the value of XL. Next, let us calculate the value of XC. See, XC is equal to, it is 1 by 2 pi fc, 1 by 2 pi fc. Okay, 1 divided by 2 into 3.142 into f is 50, how much is c? C is 90 microfarad. So 90 into 10 to the power minus 6, micro andre 10 to the power minus 6. Okay, I will get it as 1 divided by 2 into 5, 50 will be 100, 100 into 3.142 will be 314.2 into 90 into 10 to the power minus 6. I will take 10 to the power minus 6 to the numerator. I will get it as 10 to the power plus 6. And let us multiply these things now. We'll multiply these things, 314.2 into 90, right? Okay, let us multiply. See, multiply madabekadre 314.2 into 90. So this is 28278, right? 28278. Okay. Now let us divide this. 1 divided by 28278. 1 divided by 28278. So this will be okay. Otherwise, we'll do it like this. We'll do it like this. See, 10 to the power 6 enadala. Then now we'll take it as 10,000 into 10 to the power 2 divided by 28278. Right? So 10,000 divided by 28278. This will be 0.353. 0.3536 into 10 to the power 2. So if I remove 10 to the power 2, it will be 35.36 ohm. Right? So I got XC. as 35.36 ohm. Okay, compare the values of XL and XC now. XL and XC you compare. So comparing, we'll get to know that XL is greater than XC. XL is greater than XC. If XL is greater than XC, then current lags behind voltage. Current lags behind voltage. They are asking, does the current leads or lags the voltage? Current lags behind the voltage. How we got to know? Because XL is greater than XC. Okay, one more thing they are asking, calculate the phase difference between the current and voltage. They are asking us to calculate the phase difference between current and voltage. See, we know the phasor diagram. Phasor diagram namak gottadri, right? Phasor diagram is like this. It is like this. So here I will take I, right? I athwa idar mele ನೀವು R ತಗೋಬಹುದು. Here I will take XL. Here I will take XC, right? Okay, so R I will take it here. Phasor diagram ನೆನಪಿರಬೇಕಂದ್ರೆ you should know this and you should understand this very clearly. ಇದನ್ನ ನೀವು theory ಒಳಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡಿರಬೇಕು. Okay, since XL is greater than XC, the resultant of these both will be here, XL minus XC, correct? And impedance will be here. ಇಲ್ಲಿ ನಮಗೆ impedance ಇರ್ತದೆ. This is impedance ಅಥವಾ ನಾವು ಇದನ್ನ voltage ಅಂತ ತಗೋಬಹುದು. ಇಲ್ಲಿ current ಅಂತ ತಗೊಂಡಿದ್ದೀವಲ್ಲ ಹಂಗೆ ಇದನ್ನ voltage ಅಂತ ತಗೋಬಹುದು. Next, here will be the phase difference now. Phase difference ನಮಗೆ ಇಲ್ಲಿ ಇರ್ತದೆ. So I will get a triangle here. Here is the phase difference. This is R and this is XL minus XC. E side ಏನಿರ್ತದಲ್ಲ, this is parallel to y axis. ಅದಕ್ಕೆ ನಾವು ಇದನ್ನ XL minus XC ಅಂತ ತಗೊಳ್ಳೋದು. Correct? We know the value of XL, XC and R. That's why I have taken the phasor diagram like this in terms of XL, XC, R. ಇಲ್ಲಾಂದ್ರೆ ಈ phasor diagram ನೀವು VL, VC, VR terms ಆಗು ತೆಗಿಬಹುದು. That is also correct only. ನಮಗೆ known terms ಏನೋ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. Okay, then tan pi is equal to, it will be opposite side, that is XL minus XC divided by R. XL minus XC, how much this will be? XL minus XC. How much is XL? 314.2. XL is 314.2. XC is 35.36. So it will be 278.84. 278.84. Right? Divided by how much is the resistance? Resistance is 100. We got tan alpha is equal to 278.84 divided by 100. See, this will be tan alpha is equal to 278.84 divided by 100 means it will be 2.7884. So I will get it as alpha is equal to, pi is equal to tan inverse of 2.7884 2.7884. So you should observe this number. You should find this number or number very close to this in tan table, natural tangents table. Let us find it in natural tangents table. This is natural sine table. We'll go to natural tangents table now. Okay, natural tangents table. So this is natural tangents table. Natural tangents table now we have to find the number 2 point, how much it was, 2.788, right? So 2 point means the numbers are here, right? 2 point. Okay, let me check the number. So the number is 2.7884. 2.7884. Okay, 2.7884 is somewhere here. 2.7884. Okay, 2.7884. The number very close to that is 2.7776. 2.7776. So this is 70 degree, and it is in the column of, 70 degree, 0.2. See, 70 degree, 0.2 degree. So the answer will be 70.2. It will be 70.2 degrees, right? So this much it will be 70.2 degrees. Hence, the phase difference will be 70.2 degree. This much will be the phase difference, right? So we got to know how to find out the phase difference. Here current is lagging behind the voltage and the phase difference is 70.2 degree. Let us go to the next question then. Okay, this is on ray optics. An equilateral prism, prism equilateral anta, when the prism is said equilateral, then the angle of prism is 60 degree. Is made up of glass of unknown refractive index. A parallel beam of light is incident on a face of the prism. The angle of minimum deviation is 40 degree. Idu capital D, minimum deviation. Find refractive index of the material of the prism. Refractive index find madbeka. If the prism is placed in water of refractive index, this is refractive index of water 1.33. Find the new angle of minimum deviation for the parallel beam of light. Okay. Illen kottidare antandre on the equilateral prism ade namaga. We have an equilateral prism, right? So equilateral prism ade, equilateral prism andmele atrada prism angle of prism ಎಷ್ಟು ಇರಬೇಕ್ರಿ? Angle of prism will be 60 degree. ಈಗ ಇದು ನಮಗೆ ಏರ್ ಒಳಗದೆ ರೀ. This is in air. ಏರ್ ಒಳಗೆ ಇಟ್ಕೊಂಡಾಗ ಈ ತರದ ಮಿನಿಮಮ್ ಡೆವಿಯೇಷನ್ ಎಷ್ಟದ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Minimum deviation is 40 degree. Minimum deviation is 40 degree when it is kept in air. ಈಗ ಅದೇ ಸಪೋಸ್ ನಮಗೆ ಏನಾದರೂ if I take a water medium, ಈಗ ನಮಗೆ ಇಲ್ಲಿ ಒಂದು ವಾಟರ್ ಮೀಡಿಯಂ ಅದ. This is water medium, right? So this is water medium. ಈ water medium ಒಳಗೆ ಈಗ ನಮಗೆ ಅವರು ಏನು ಮಾಡ್ಕೊಂಡಿದ್ದಾರಪ್ಪ ಅಂತಂದ್ರೆ, in the water medium they have kept the prism now. Okay, this is the water medium, and in that water medium a prism is kept. Okay, so this is the equilateral prism which has been kept in the water medium, right? Okay, so this is water. This is water. Refractive index of water is given. It is 1.33. So nodri, ಈಗ ಅದೇ ಸೇಮ್ ಪ್ರಿಸಮ್ ತಗೊಂಡು ಬಂದು ಇಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ, ನೀರಿನ ಒಳಗೆ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ. ದಿಸ್ ಇಸ್ ದ ಸೆಕೆಂಡ್ ಕೇಸ್. ಇದು ಸೆಕೆಂಡ್ ಸಿಚುವೇಶನ್, ಇದು ಫಸ್ಟ್ ಸಿಚುವೇಶನ್. ಏರ್ ಒಳಗದೆ, ಇಲ್ಲಿ ವಾಟರ್ ಒಳಗದೆ. ಸೊ ಇಲ್ಲಿ ಮಿನಿಮಮ್ ಡೆವಿಯೇಷನ್ ಎಷ್ಟಾಗಬೇಕು? ಹೌ ಮಚ್ ವಿಲ್ ಬಿ ದ ಮಿನಿಮಮ್ ಡೆವಿಯೇಷನ್? ದಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್. ಸೊ ದಟ್ ಇಸ್ ದ ಕ್ವೆಶ್ಚನ್. ಫಸ್ಟ್ ಥಿಂಗ್ ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಹಿಯರ್. ನಾವು ಮೊದಲು ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು, ಆಮೇಲೆ ಮಿನಿಮಮ್ ಡೆವಿಯೇಷನ್ ಇನ್ ವಾಟರ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. Okay, refractive index of a prism is given in terms of minimum deviation. Minimum deviation angle ಒಳಗೆ ನಮಗೆ ಇದನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ a plus d by 2. In theory we have derived this a plus d by 2 divided by sin a by 2. Divided by sin a by 2. Okay, sin a plus d by 2. So this will be sin a is 60 degree, d is 40 degree. So ಇದು ನಮಗೆ ಆಯ್ತಾ 100 divided by 2, right? And sin 60 by 2 ಅಂದ್ರೆ ಇದು sin 30 degree ಆಯ್ತು ನಮಗೆ, ಕರೆಕ್ಟ್? ಸೊ sin 100 by 2 ಅಂತಂದ್ರೆ ಇದು ನಮಗೆ sin 50 degree ಆಯ್ತು ರೀ. This is sin 50 degree and this is sin 30 degree. Sin 30 degree ಅಂದ್ರೆ ಎಷ್ಟು? 1 by 2. So I can take it as 2 into sin 50 degree. 2 into sin 50 degree. Okay, now see the value of sin 50 degree. Natural science table ಒಳಗೆ ನೋಡ್ಕೋಬೇಕು ಇದನ್ನ. Sin 50 degree, you have to see it in natural science. So this is natural science. So sin 50 degree I want. So where is 50 degree? 50 degrees here. Okay, this is 50 degree, right? 50 degree. First column ಒಳಗನ ಅದರ ವ್ಯಾಲ್ಯೂ ನೋಡ್ಕೊಂಡು ಬಿಡಬೇಕು. So how much it is? 0.7660. 0.7660. Okay, 0.7660. So this will be 0.7660. ಇದು ನಮಗೆ 2 ಅದರಿ, into 2. Okay, let us multiply that now. We'll multiply. Okay, let us multiply. It is 2 into 0.7660. So it is 1.532. So 1.532 is the refractive index of that prism. Our prism, the refractive index namak banta, it is 1.532. Right? This much is the refractive index. See here, when the light beam was entering the prism, first medium was air. First medium was air and the second medium was glass. Second medium was glass. Illi bandaga, when it is kept in water, when the light is entering the prism, first medium is water. First medium is water and second medium is glass. Second medium is glass. Right? So medium namak change agitri, surrounding medium change agitri. I will use the same formula. N is equal to sin A plus D. A plus D badli na illi A plus D dash anta tagothenri. New angle of minimum deviation. A plus D dash divided by sin A by 2. Right? A antu same adri. Yakandre prism change madidna. Prism is same. Refractive index of the prism is also same. So ಇಲ್ಲಿ ನಮಗೆ ಏನು ಬಂತಲ್ಲ, this is refractive index of prism. Prism glass ದಿಂದ ಮಾಡಿರ್ತಾರೆ. So this is the refractive index of glass of the prism. ಆ prism the glass is refractive index ಅದು. Refractive index of water ನಮಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. Refractive index of water. ನೋಡ್ರಿ ಇಲ್ಲಿ ಏನಿರ್ತದಲ್ಲ, this is relative refractive index. ಇದು relative refractive index. Relative refractive index ಅಂತಂದ್ರೆ ಅದು ನಾವು ಹೆಂಗ್ ಬರೀತೀವಿ? N21. This is nothing but refractive index of second medium divided by refractive index of first medium. That is how we have to write. So the N21 ಏನದಲ್ಲ, ಈ N21 I will write it like this. Refractive index of second medium. Second medium is glass and first medium is water. First medium is water. So I can write it as refractive index of second medium divided by refractive index of first medium. N2 by N1. Refractive index of glass divided by refractive index of water. So I will get it as sin A plus D dash divided by 2 and this will be sin A by 2 andre 60 by 2, that is sin 30 degree. Sin 30 degree andre it will be 1 by 2. Right? Illi namagu bandade 1 by 2. Okay, refractive index of glass, it is 1.532 divided by refractive index of water, that is 1.33 equal to sin A plus D by 2 divided by 1 by 2. Correct? Let us divide this now. We'll divide this 1.532 divided by 1.33. Right? ನೋಡ್ರಿ ಈಗ ನಾ ಇಲ್ಲಿ 1.532 divided by 1.33 ತಗೊಂಡಿದ್ದೀನಿ. ಇನ್ ಕೇಸ್ ನೀವು 1.53 divided by 1.33 ತಗೊಂಡ್ರೆ you will get a little bit different answer. ಸ್ವಲ್ಪ ಚೇಂಜಸ್ ಆಗ್ಬೋದ್ರಿ. ಸೊ ಡೆಸಿಮಲ್ ಪಾಯಿಂಟ್ ಆಗಿದ್ಮೇಲೆ ಎಷ್ಟು ಡಿಜಿಟ್ಸ್ ತಗೊಂತೀವಲ್ಲ ಅದ್ರ ಮೇಲೆ ಆನ್ಸರ್ ನಮಗೆ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗ್ತದ್ರಿ. ಭಾಳ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ, ಬಟ್ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗ್ತದೆ. ಸೊ ದೇರ್ ಇಟ್ ಮೇ ಗೆಟ್ ವೆರಿಡ್. ಸೊ ಇದು ನಮಗೆ 1.151 ಅದರಿ. ಸೊ ದಿಸ್ ಇಸ್ 1.151. Okay, let me take it as 1.15. Okay, ಇದು half na ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀನಿ. If I multiply that half to this, it will be 1 by 2 and this is same sin A plus D dash divided by 2. ಇದು as it is ಅದ LHS ಒಳಗೆ. Okay, let me continue this here. ಇಲ್ಲಿ ನಾ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ. So ಇದು 1.15 divided by 2 ಅಂದಂಗ್ರಿ. 1.15 divided by 2. 1.15 divided by 2. That will be 0.575. Okay, this is 0.575 equal to ನಮಗೆ ಏನದಪ್ಪ ಅಂದ್ರೆ sin A plus D dash divided by 2. A plus D dash divided by 2. I will write it like this. I will take sin on this side. So sin inverse of 0.575 equal to A plus D dash divided by 2. A plus D dash divided by 2. Okay. Sin inverse of 0.575. Sin inverse of 0.575. So 0.575 ಗೆ ನಿಯರೆಸ್ಟ್ ನಂಬರ್ ಹುಡುಕಾಡ್ರಿ. ನ್ಯಾಚುರಲ್ ಸೈನ್ಸ್ ಟೇಬಲ್ ಒಳಗೆ 0.575. So where is 0.575? Here it is. 0.575. ಇಲ್ಲದ ನಮಗೆ 0.575. So it is in the row of 35 degree and it is in the column of, see, let me take it here, 35. Second column ಹೋಗಿದ್ರೆ 575, 0.575. So 35.1 degree. Second column ಅಂದ್ರೆ 0.1 degree. 35.1 degree. So it is 35.1 degree. So here I will write it as 35.1 degree equal to A plus D dash divided by 2. ಆ 2 ನ ಈ ಕಡೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋತೀನಿ. 35.1 into 2 that will be 70.2, right? So 70.2 A plus D dash. So ನಮಗೆ d dash ಬೇಕಾ, d dash is equal to 70.2 minus a ಅಂದ್ರೆ 60 degree. So it will be 10.2 degree, 10.2 degree. So minimum deviation is 10.2 degree, right? Minimum deviation is 10.2 degree. So that's all about the numericals, 5 marks numericals in model question paper 1 of academic year 2024-25, right? So innu ಎರಡು model question paper adava. If this is helpful for you, please put a comment. And if you need anything else, please put a comment. I will surely do the video on that. And if this is helpful, we'll continue this, we'll solve the numericals from model question paper 2 also and 3 also, right? Thank you so much for watching the video and supporting the channel. Please keep watching and supporting the channel. If you like the content, please don't forget to subscribe the channel and share the channel at any cost, right? Please share and please keep support. Thank you.